Imagine a star, its light fading at random, unpredictable intervals, and scientists still have no idea why. On March 7, 2009, the Kepler Space Telescope entered orbit around the Sun, with its primary mission being to search for habitable worlds. To do this, Kepler relies on the transit method. It watches a star continuously and measures its brightness. When a planet passes in front of that star, even for a moment, its light drops slightly. If these dips repeat with a regular rhythm, scientists know there is a planet orbiting the star. By studying these tiny changes, telescopes like Kepler can learn a planet's size, orbit, and distance from its star. Under normal circumstances, a star that dims and brightens in a steady pattern is simply being crossed by a planet. In 2015, a star known as Tabby's star suddenly captured global attention. Its light began fading and brightening in ways no one had ever seen before. The dimming was far too large, far too irregular, to be explained by a simple planet passing in front of it. At times, the star's brightness dropped by up to 22%, sometimes for only a few hours, and other times for days, even weeks. Nothing about this behavior matched anything astronomers had observed in any other star. For comparison, a planet the size of Earth dims its star by only fractions of a percent. Even a giant like Jupiter causes no more than a 1% drop. But Tabby's star dimmed by 22%, nearly 20 times stronger than anything Jupiter could produce. Whatever was blocking the light had to be enormous, irregular, or made of countless large fragments moving together. Scientists proposed several possibilities. Some believe the dimming may come from a swarm of comets or a large cloud of interstellar dust drifting in front of the star. Others suggest the dips might be caused by a small black hole located somewhere near Tabby's star. Another idea points to a planetary collision within the system, creating debris that could temporarily block the star's light. But if such a massive impact had occurred, Tabby's star would emit far stronger infrared radiation. A collision of that scale produces intense heat and dust, yet observations reveal no infrared signature at all. But there is another idea, one far more intriguing. Some scientists suggest that the dimming of Tabby's star might be caused by a massive structure built by an advanced civilization. In this theory, such a civilization could have constructed a huge energy-harvesting megastructure around the star, much like the legendary Dyson Sphere. If such a structure exists, its passing segments could explain the sudden, irregular drops in Tabby's light. It may sound unbelievable, but the star's behavior has never fully matched any natural explanation we know. And if an advanced civilization truly exists out there, building a Dyson Sphere might be entirely within their capability. Such a civilization, needing ever-increasing amounts of energy, would eventually begin constructing colossal structures to harvest power on an unimaginable scale. This idea echoes the theory proposed by physicist Freeman Dyson, who suggested in the 1960s that advanced civilizations might build giant structures around their stars to capture their immense energy, a concept now known as the Dyson Sphere. According to Dyson, once a civilization exhausts the resources of its home planet, it must look outward, to its own star, to survive. To do that, it would need to build vast energy-collecting panels or even an enormous spherical shell surrounding the star. Such a megastructure would absorb most of the star's light, and from a distance, astronomers would observe irregular dips in its brightness, exactly what we see in Tabby's star. To understand how advanced such a civilization might be, we turn to the Kardashev scale, which classifies civilizations by the amount of energy they can use. Type 1 civilizations can harness all the energy available on their home planet, from the atmosphere, winds, and oceans to geological forces like earthquakes. Humanity has not yet reached this level. Type 2 civilizations can harvest all the energy produced by their star. They can transform uninhabitable planets in their system into livable worlds, colonize them, and mine asteroids on a massive scale. Such a civilization would face a very low risk of extinction. Their only real threat would be another civilization even more advanced than themselves. With technology this advanced, they could control life at the cellular and even atomic level, eliminating disease, aging, and many biological limitations entirely. For this reason, some researchers believe that such a civilization might exist around Tabby's star, perhaps even harvesting its energy right now. Type 3 civilizations reach a level where they can control the entire energy output of their galaxy. At this stage, not a single star system, but an entire galaxy becomes their domain. They could turn stars and black holes into colossal power sources, build vast galactic empires ruled by advanced artificial intelligence, and establish communication networks stretching across light years. Some theories even suggest they might travel between galaxies and reshape the laws of physics for their own purposes. Reaching such a level of advancement is far beyond anything humanity can imagine today. Even the most optimistic estimates say it would take millions of years. And as for Tabby's star, we still cannot say with certainty whether its strange fluctuations are caused by a natural process or by a massive structure built by an advanced civilization. When we move past speculation, the explanation most supported by scientists today is the presence of a dense cloud of dust and debris orbiting the star. Maybe it really is just a cloud of dust, or something we simply do not yet understand. But who knows? Perhaps there truly is someone behind that fading light.